Hello, I've been asked by Respawn Entertainment to figure out how to normalize vectors efficiently by deciding between using the fast inverse square root method or the modern method for their upcoming game Call of Duty Modern Warfare 34.5.2. So, what is a vector and why do I want to normalize it? Well, a vector is a direction with a magnitude. So, in every game engine, there's a physics engine that does these calculations automatically, and it does it for a plethora of things. Every single time you see sunlight or a lamp, the sources of light and where the light shines, those are calculated using vectors. Whenever you have a projectile like a bullet or an arrow, those are also being calculated using vectors. In addition, those are also calculated with gravity. So let's say your game is running at 100 frames per second. On each frame, the physics engine is updating the arrows with a new vector calculation because it's applying gravity. So you get a new arc, a new speed, etc. And on top of that, let's say it's an explosive arrow that hits a building. The light from that explosion requires vectors, and on top of that, the rubble that's formed and falls, each piece requires vectors. So when you're doing a game with dozens of players with hundreds of arrows, each being calculated hundreds of times per second, which are creating their own effects and cascading into even more vectors, you can end up with millions of calculations per second. So it's important to optimize it because any time saved there can severely impact game performance positively. So how you calculate a vector is doing x squared plus y squared plus z squared and its square root. It's essentially the Pythagorean theory. But the important thing to note here is that a physics engine needs it to be normalized. It needs to be on a scale of a unit of 1. The reason this is important is because if you don't do so, you feed in some random numbers such as 1.357, the physics engine may not properly calculate it using that number, and therefore you end up with an arrow that's not traveling 40 miles per hour, but 40,000 miles per hour, which you don't want. So you need to normalize it. The issue is to do that, you have to do that for the x, y, and z coordinate, and then feed that information in. And so as you can probably tell from looking at this, each calculation of a vector requires 9 multiplications, 6 additions, 3 square roots, and 3 divisions. Multiplication and addition isn't too bad. It's quite quick on a processor, but division and square rooting takes up a ton of time, which is bad. So conventional methods tell you just get a library or a header file. The previous programmer has already optimized it as best as they can. So you just do 1 divided by square root of x. And while that is faster, it's not much faster. So in the early 2000s, the developers of Quake 3 Arena were trying to implement their own method. So for the sake of brevity, we're going to skip the first 5 lines of code except for the float y, which is important. What we're going to skip to is the evil floating point bit hack line. What's important here is if you remember that a float you cannot perform bit manipulation on because it has to be in the format of 1, the first bit is a 1, the next 8 bits are an exponent, and the remaining bits are the mantissa bits for capacity. So you then cast the address of the float as a long, so the C compiler thinks it's a long, so you can perform bit manipulation on it. You then figure out that you can equivalently do the same thing by instead of doing the inverse square root, you take the negative 1/2 log of the variable. What's important here is the 1/2 represents the square root, the square rooting. So because you can now do bit manipulation, you shift to the left. So instead of shifting by 1/2, you shift the exponents over by 1 in the actual code. So what that ends up doing is that does a square rooting, but only in one instruction, which is the bit shift. In addition, you can just do logarithms on a computer, which is much quicker than either division or square rooting. And you subtract that from a preset amount, which is that weird looking number in hex. In addition, the last step is the Newton iteration approximation, which is some math boogaloo. But essentially, by doing these steps, you go from doing 9 multiplications, 6 additions, 3 divisions, and 3 square rooting to just 9 multiplications, 3 subtractions, and 3 bit shifts, which is roughly 8 times faster. Now the issue is processing companies such as Intel and AMD, but predominantly Intel because they did first. They came up with a chip component that they put in their processors in early to mid 2000s, which allows how to do this natively and automatically. So it ends up being roughly 4 times faster than the square root method. So basically the square root method is practically obsolete at this point, as you can, whenever you reference a library, it automatically goes to this component and says use this to calculate it. So the modern method is the way to go.